All right, let's start using what we know about trig functions and inverses to start solving trig equations. Start with a nice simple one here. 2 cosine x minus 1 equals 0. In order to solve this one, we want to move all the simple arithmetic stuff over to the other side first and just get the trig part alone. So of course we're going to want to add 1 to both sides. So we'll have 2x, or 2 cosine of x is equal to 1 and divide by 2. All right, now we can finish this up in a couple of different ways. One way that you can do it is you can get rid of cosine by using inverse cosine. So we would actually take the inverse cosine of cosine x is equal to inverse cosine of 1/2. Right? Then algebraically, an operation that's inverse will cancel each other, and we'll have x is equal to the inverse cosine of 1/2. Now if you go over to your calculator and type in inverse cosine of 1/2, you might get something like 60, meaning 60 degrees. Of course, there's a couple things wrong with that. First of all, we were asked to solve over the interval from 0 to 2 pi, which means we can't have our answer in degrees. Instead, it would have to be in radians. So that's the first thing. The other thing is 0 to 2 pi is one entire trip around the circle. When you use inverse cosine, remember that we limited the domain so that we would only get one unique value. But if we're talking about going all the way around the unit circle, what inverse cosine of 1/2 did was found this angle. All right, this is our angle x, for which cosine of x is equal to 1/2. But that's not the only spot on the unit circle that does that. Remember that every ordered pair, every point on the unit circle, xy is cosine theta, sine theta. So we need to find the other quadrant for which cosine would be positive. Right? Since cosine is the x-coordinate, that would be over here. And we need that same pi over 3 angle that's in the fourth quadrant. So if this angle here is pi over 3, that would mean our other answer is 5 pi over 3. In general, not always, but in general, when we're solving over one entire trip around the circle, we're going to end up with 2 answers. So if we're going to solve for cosecant x plus 2 is equal to 0, kind of same plan. Let's get that cosecant alone. Cosecant of x would equal -2. And I like looking at things in terms of sines and cosines. And since cosecant is the reciprocal of sine, that would mean that sine is going to be -1/2, the reciprocal of 2. To finish it off, we would take the inverse sine of both sides and go over to our calculator and type in the inverse sine of -1/2. And your calculator would probably give you the -30 degrees, which is -pi over 6. And we got to check to make sure we got it right. Going back to our condition, we're supposed to have our answer between 0 and 2 pi, which everything between 0 and 2 pi is a positive number, not -pi over 6. So we think about our unit circle. And where is -pi over 6? It's going to be right down here. Right? This is -pi over 6. Now the other way to express that would be as a positive coterminal angle, and that'd be 2 pi minus that pi over 6, which is 11 pi over 6. And that's not the only answer. We should be looking for 2 solutions to each trig equation like this. So I need to know the other quadrant for which sine is going to be negative. Okay? Going back to this line of our work. And since sine is the y-coordinate, y is negative below the x-axis, so I'd be over here in the third quadrant, which means I need the pi over 6 angle that's in the third quadrant. Thinking about the position angle from here, that would be 7 pi over 6. That 1 pi plus another pi over 6. How about tangent squared minus 1? Of course, we get that tangent alone, so we'll have tangent squared of x is equal to 1. And then we have to square root both sides. And when I take the square root of both sides, be careful. Yeah, we'll get that to cancel and just be left with tangent, but on the right side, square root of 1 is not 1. It's going to be the plus or minus 1. So we really have two equations to solve. Where is tangent of x equal to 1? And where is tangent of x equal to negative 1? Of course, you can go ahead and type in your calculator to get you a degree angle, or we can think about our unit circle. When it comes to tangent, tangent is sine over cosine. We need to sine over cosine to equal 1. So let's just visualize that real quick. Sine over cosine has to equal 1, which would mean the numerator and the denominator have to both have the same value, and that happens right here at pi over 4. So when tangent of x is equal to 1 is when x is pi over 4. Now I need to think about when, in which other quadrant, is tangent also positive, and that would be over in the third quadrant. So I need the pi over 4 angle that's in the third quadrant. So pi plus pi over 4 is 5 pi over 4. Moving on to the negatives, well, to get a negative 1, tangent of x being negative 1, we would need sine and cosine to have opposite signs. That's going to happen in the second and the fourth quadrant. So we need the pi over 4 angle that's in each of those quadrants. The pi over 4 angle that's in the second quadrant would be 3 pi over 4. And the pi over 4 angle that's in the fourth quadrant is going to be 2 pi minus that pi over 4. So 8 pi over 4 minus pi over 4 is 7 pi over 4. When we're looking at something like tangent squared of x is equal to tangent of x, your instinct might be, oh, wait a second, I could just divide both sides by tangent. Get those ones to cancel and this one to cancel with one of those, and we would have tangent of x is equal to 1. But don't do that. If you do that, you end up getting rid of some of your answers. Let me show you why. What we should do is to bring all of the trig functions over to one side first, so that we'll have tangent squared minus tangent is equal to 0. And instead of dividing by tangent and getting it to cancel, what we're going to do is to factor that tangent out of this expression, and we'll be left with tangent minus 1. So we have two factors that when multiplied together equals 0, and we have that 0 product property. This says that the tangent of x would have to equal 0, or the tangent of x minus 1 would have to equal 0. So tangent equals 0, or tangent equals 1. Notice that when we divided by tangent in our first attempt, we ended up with this equation. But what was missing is that other equation of where tangent is equal to 0. So let's think about our unit circle and start trying to solve these equations. I'm going to solve that tangent of x is equal to 1 first because we just did that one. Remember, we needed sine and cosine to be the same because tangent is sine over cosine. And if we want that to equal 1, numerator and denominator have to be the same. That's going to happen when x is pi over 4. The other quadrant where tangent is positive is going to be in the third quadrant. And so the third quadrant, pi over 4 angle, is going to be pi plus that pi over 4, which makes 5 pi over 4. Now when we want to solve the other equation, tangent of x is equal to 0, I think about that still that same fraction, sine over cosine. It's just now I want that to be equal to 0, which would mean sine would have to equal 0. And sine is 0 when the y coordinate is 0. So right here, that's when x is 0. And the other spot is on the other side of the x-axis, so at pi. Then here are our 4 solutions. Let's do another one that takes some factoring. 2 sine squared of x minus sine of x minus 1 is equal to 0. And if we're going to factor that, we're going to factor 2 sine squared x into 2 sine of x and sine of x. Factoring the 1 into 1 and 1, we need to have a minus 1 sine of x on the inside, so that would make 2 sine of x, that would make 1 sine of x. If I need a negative 1 sine of x, we start with negative 2, and then add 1. So here is our factored form. Since we have 2 factors whose product is 0, that would mean that each factor, 2 sine of x plus 1, could equal 0. So either 2 sine x plus 1 equals 0, or the sine of x plus minus 1 is equal to 0. That would mean that subtracting 1 and dividing by 2, sine of x is equal to negative 1/2, or from this equation, sine of x would equal 1. So, thinking about our unit circle again, solving each of these, where is sine of x equal to negative 1/2? Well, that would have to be in the 4th and the 3rd quadrants. The pi over 6 angle that's in each one of them would be the pi over 6 angle that's in the 3rd quadrant is 7 pi over 6. That would be pi plus pi over 6. And the one that's in the 4th quadrant would be 2 pi minus pi over 6. So 11 pi over 6. And when is sine of x equal to 1? That's only going to be in one spot, right up here at pi over 2. So we'll only have 3 answers for this one. All right, now we have a trig equation that's involving sines and cosines. If we just jumped into it and started to factor, we would factor that 2 sine squared into 2 sine of x and sine of x, and start factoring that 3 and maybe guessing and testing 1 and 3. But when we start looking at those products, there's no way that I'm going to multiply 1 times sine of x and 2 sine of x times 3 to get something that's cosine. So we got to go back to the beginning. And before we can start factoring and using those rules of algebra, we're going to have to use some trig identities first. And one thing I do know about sine is that it's part of that Pythagorean identity. That being that sine squared plus cosine squared is equal to 1. Which means over here I can replace that sine squared with 1 minus cosine squared. And continue with the rest of our equation. When we simplify that, we'll distribute the 2. And combine like terms. So we'll have a negative 2 cosine squared plus 3 cosine minus 1 equals 0. Now, I don't know about you, but I hate dealing with a negative leading coefficient. So what I'm going to do is take everything, bring it over to the other side. So that would mean I would have to add 2 cosine squared, subtract 3 cosine, and add 1. Now I have something that I can go ahead and try and factor. Factoring 2 cosine squared would be 2 cosine and cosine. We factor 1 into 1 and 1. And if I want a negative 3 cosine, I would need negative 2 cosine minus 1 cosine. Now I got the product of 2 factors that equals 0. So either my first factor equals 0 or the second factor equals 0, which means cosine would have to equal 1/2, or cosine would have to be 1. So let's go over to our unit circle and start thinking about solutions to each of these equations. Cosine is going to equal 1/2 when the x-coordinate is 1/2. So that's when x is pi over 3. The other quadrant where cosine is positive, since every point on the unit circle, the x-coordinate is cosine, so we would need a positive x-coordinate that would have to be in the 4th quadrant. So I need the pi over 3 angle that is in the 4th quadrant. So 2 pi minus pi over 3 would be 5 pi over 3. And then for cosine of x is equal to 1, that's when the x-coordinate is equal to 1, which is right over here. So when x is equal to 0. Now notice that I didn't also say 2 pi. That's because, going back to my conditions, we're trying to solve for all x's between 0 and 2 pi that include 0 but does not include 2 pi. Let's try one last equation, this one involving cosecant. We see we got a cosecant to the 4th minus 4 cosecant squared. So just like before, we're not going to divide by cosecant squared. Instead, we'll factor out the cosecant squared, and we'll be left with cosecant squared minus 4 is equal to 0. If we set each of these equal to 0, we'll end up with cosecant squared is equal to 0, or cosecant squared minus 4 is equal to 0, or cosecant squared is equal to 4. We can get rid of the squares by square rooting. So cosecant is equal to 0. When we square root here, we're not going to get cosecant is equal to 2. Instead, we'll get cosecant is equal to 2, or cosecant is equal to negative 2. Okay. So we actually have 3 separate equations that we have to solve. And I don't like solving them from cosecants. Instead, like I said before, I like it much better thinking of them in terms of sines and cosines. Since cosecant is a reciprocal of sine, that would mean that sine is 1 over 0, or sine is 1 over 2, or sine is negative 1 over 2. And of course, sine of x being undefined, that doesn't happen anywhere, so we won't end up with any solutions from here. We just have to think about the sine of x being 1/2 or negative 1/2. So let's go back to our unit circle. Sine is 1/2 at the pi over 6. Okay, so that would mean x is pi over 6. And the other quadrant where sine is positive is going to be the 2nd quadrant. So that would be pi minus that pi over 6, which is 5 pi over 6. And then where sine is going to be negative is going to be those pi over 6 that are in the 3rd and the 4th quadrant. So pi plus pi over 6 is 7 pi over 6. And 2 pi minus that pi over 6 is 11 pi over 6. So we end up with our 4 solutions there.